Today you're going to learn about how to calculate the volume of pyramids and cones. Now, you've dealt with these shapes before, but what you may not realize is that there's more than one type of pyramid. When people think of the word pyramid, but really, the base of your pyramid could be any polygon shape. Because a pyramid is technically defined as a polyhedron with only one base of any polygon shape, and all the lateral faces being triangles that meet at a common vertex. See how for each of these, the lateral sides that aren't the base are all triangles that meet at a common vertex at the point? So these are all types of pyramids that you'll be dealing with in this chapter. When you want to calculate the volume of a pyramid, you're going to use this formula, area of the base times height of the pyramid, all over 3. The reason why this is your formula is because, really, the space a pyramid takes up three-dimensionally is a third of the space a prism takes up with the same base area and height. That's why it's that familiar area of base times height as part of the formula, because that's the prism that contains your pyramid divided by 3. So for a problem like number 1, notice how they tell you in the intro that for this section they're all square-based pyramids. So that can streamline your problem a tad, because you know that you could calculate for a square the area by multiplying base times height, but they're going to be the same number. If the base is 12.5, for a square the height will also be 12.5. So a shortcut, for the area of the base when it's a square, just say it's 12.5 squared. And then you plug in the height of your pyramid, 16, and you divide by 3. Some of you have calculators where you could type this all in one go. Some of you guys will have to square this first, press enter, and then times 16 divided by 3. See what works for you. But you should get something a little bit over 833. And then because it's volume, don't forget your units are cubed. We're talking about 3-dimensional space. How much space is inside your shape? Pause here and try question 2 on your own. You should get a ridiculously large number. Some of you might notice your calculators have it in scientific notation if the screen's kind of short, so it might be 9.22 times 10 to the power of something, but this is really the number it stands for. Now, notice how for both of these problems, they're telling you all the information you need right from the beginning. They're telling you the sides of your square so you could find the area of the base, and they're telling you the height of your pyramid. Sometimes you might have to figure out what information picture you actually need to use. So for example, on number 3, see how there's 2 different heights here? Which one are you going to need? You're going to need to use the one that is telling you how tall the pyramid actually is. That'd be the 30. So you never use this 34 height at all because it's what we call a slant height. It's telling us the height of the triangle side, but it's not telling us how tall the pyramid actually is. It's on the outside of the shape, telling us the height of the lateral face, if we picked it up and straightened it out. So make sure you use the inside height, the actual height of your pyramid for volume. 4 is similar to 3, except notice how they don't tell us the inside height at all. This is another slant height, telling us the height of all the triangle faces, but not actually how tall the pyramid is from the center up. So when they don't tell us the height we need, here's what you're going to do. You're going to first draw the height we need down the center of the pyramid here and label that X. And then if this slant height is 15, then the slant height of all the sides is 15. So down the middle of the triangle side here, that's easiest to see with how they drew the picture, draw that slant height and label it 15. And then if all the sides of the base of the pyramid are 18s, and the height starts at the center of the pyramid, then if this side is 18, then half of that would be 9. If it starts at the center of the pyramid, it goes to the edge. Notice how it makes a right triangle. And you can use Pythagorean's theorem to solve for the missing height. So make sure you label the hypotenuse side, the longest side, C. Doesn't matter which one's A or B. plug that into Pythagorean's theorem, and you get that the missing height is 12. Now you can plug that in. Pause the video here and plug in your height and the area of the base and see what you get. Check your answer. Solving for the volume of cones has a lot of similarities to solving for volume in pyramids. So a cone is defined as a solid with one base that's a circle and one vertex. Notice how the definition is pretty similar to that of a pyramid in terms of having only a single base and everything else narrowing to a single vertex or point at the top. The difference is your base is a circle instead of a polygon. Because it's very similar to a pyramid except with a circle base, you could take the pyramid formula of area of base times height over 3 and replace the capital B with the area of a circle, pi r squared. So your formula for volume of a cone becomes pi r squared times h over 3. Pause here and try the first problem on your own. Leave your answer in terms of pi. When you plug in the radius of 5 and the height of 12, you should get 100 pi cubic meters. Pause here and try the next one on your own. Notice how this time they don't tell you the actual height of your cone. They're telling you the slant height of the side instead. So you're going to do something quite similar to what you did with question 4. You're going to draw the actual height down the center of the cone. And if the whole diameter of the circle side is 8, then the radius is 4. See how that makes a right triangle? You would then use Pythagorean theorem to solve for the actual height. You should get around 10.2 for the height of the cone. Pause here and now plug everything into your formula for cone volume and see what you get. You should get around 54.4 pi. Now you're not quite done because this is a word problem that's asking how many cubic centimeters of water does a paper drinking cup hold, implying that they don't want it in terms of pi, they want something more useful in reality. So actually take 54.4 and multiply by pi. Now, sometimes you're going to see an oblique cone. When that happens, remember Cavaleri's principle, the one that says you could straighten it out and it would have the same volume as a normal shaped cone that wasn't leaning or slanted like this. So first you'd figure out if you straightened it out what the radius would be. The radius would be half of the diameter of 8, 4. And the height is 6. So you would plug that in to your volume formula and get 32 pi cubic centimeters. Pause here and just try number 8 on your own. You should get 320 pi cubic inches. Now, for word problems where they tell you the volume of the cone, it's always a good idea to sort out the information they give you and what they're asking for. So I like to summarize on the side everything they tell me. They tell me volume, they tell me height, and they're asking for radius. Since they're telling me the volume of a cone, I'm going to start with the cone formula and plug in what I know, V and H. Now our goal is to solve for r, so we're going to get r squared by itself. We could cancel out the over 3 by doing the opposite of divide by 3. So multiply both sides by 3. And then we could cancel out both the pi and the 8 that are multiplied by the r squared by dividing by pi and 8. Once you get r squared by itself, you can square root to get rid of the square. You get that the radius is 3 centimeters. Great job, everybody. Don't forget to turn in a picture of your notes when you're done.